Okay, everyone, it seems that it's working, so I'm going to talk about quite related topic, but from slightly different perspective. It's about deploying machine learning models, and the subtitle is Model as a Code. So that's the bottom line of all my slides is Model as a Code. But let's first start about one question. Rado has always slightly touched on that, but quite unrelated. So how many of you do modeling? And because we have such a low number of ladies here, the question is not QBiz. So obviously we mean machine learning modeling. So please raise your hands. How many of you are actually modeling? And who's more in, let's say, dev type of things? Who's developer? A few devs. Good, good. And then there are business experts. Yeah. Okay, so this is going to be sort of, let's say, at the edge between more modeling and dev. I'll give you some practical examples. You will find the code on Matlab, and you can use it. You can try it for yourself. And how many of you run models in production? How many of you? A few. Good, good. Machine learning models. That's quite a lot. Yeah.
Not myself.
It's in the environment. Okay. Yes. And related question: how many of you sleep well? See? Okay, so what we're going to talk about today is, of course, a bit of interaction. That's what we are covering now. Then, fundamental question, is my model running? And what version, of course. Then we briefly touch on the model management cycle, which is some corporate stuff. You have usually guidelines if you're a larger corporation. Or if you're a startup, you have no guidelines, you just, let's run it. And then I give you hands-on example how to run model in production. It's going to be machine learning model. When you see it, that's why I'm doing that. We're going to estimate it, serve it, and deploy it. Everything is going to be done on Docker Swarm, not Kubernetes, because for us as a small company, running Swarm cluster is slightly ops cheaper because it's less complicated than Kubernetes. But this is going to connect to the real cluster. It's going to deploy it to the real cluster, and everything is going to be real and hands-on. So, quick introduction. I'm founder at the Searpent, and today, a few minutes before I came here, we finally signed the seed funding, so we are on the map. So you will see some press releases. Of course, we are hiring. Since from this moment, we are hiring. And myself, yeah, I did usually statistics and econometrics. Then it started being cool calling data science, so I started to call myself data science. But basically, I've been doing it since school. And then I more arrived to dev and CI/CD type of things, which is something that's also quite useful. So, is my model running? Everyone from corporate, you know something that looks very similar. You basically design a model because there is some business requirement. Somebody says, well, we need a new scorecard. Credit risk, very simple. Or we need something more fancy about predicting some, let's say, commercials and things like that. So you design a model. Then you somehow get the data, estimate it, you deploy it, you run it. In the perfect world, you get a feedback if it's running well, if it's doing what it's supposed to do. Then you adjust and do it again. So each of these cycles is sort of a new version of a model, right? I'm going to cover this little triangle, sort of estimate, deploy, run. This is slightly more complex topic, and it's for a full different presentation. And this is something that you probably know better than I do, so I'm not going to talk about how to do machine learning. You know it better. So I say as a code. I said each of these cycles is a new version. So if you think about it, in the past, all the devs knew that you should version your code, right? You used, I don't know, subversions, Git, things like that. But then the big thing came the infrastructure as a code. For those who are not devs, that means that basically setting up the computer where your code is going to run is also described by code, which is very good when something fails, so you can start it again next to it with no downtime almost, because you know what to start it. It's not like 3 guys panicking and installing all the dependencies on a computer. I guess some of you know it, these panic nights. And then there is the next big thing, and you can see that all the big players are sort of going towards that. Either it's Google, Facebook, and all these leaders in machine learning basically treat machine learning scripts as a code as well. I mean, we have repositories, so why not use it? So this is a code. You can always commit it to the repositories. Source data, some scripts, some SQL scripts, how you get the data. It can be also part of the version of the model that you're running. And the modeling sample has to be stored and versioned. That's important. It's important for regulatory reasons for banks and insurance companies, but also it's important for startups and smaller companies that you actually know what you're running. So if you know what you're running, you can get their feedback, and then you can improve the models. Once you have no idea which version is running, then what you do, again, both fingers crossed, next version is going to be better. Some, hand waving and some, let's say, anecdotal evidence that, oh, well, I feel the model is not working really well. Why? Because I've seen it in one case. Okay, should I do it again? Right? You see where I'm going. I guess you all sort of have this feeling that sometimes you have no idea, basically. So what we are going to do, that was the introduction. So I'm going to show something slightly less complex than Rado did, but again, it has some merits. So I have some very simple front-end application. It's a little app where you enter 2 numbers, and then you expect model deployed on a Docker swarm to do some linear combination, just multiply it and give you back the number. To make it very simple, we also give the version of the model in the app. So I'll show you the app. So I'll be doing a lot of alt tabbing as well. You see it? No, you don't see it. And that's the intricacies of presenting with things like this. So I will do the trick that Rado did, to duplicate the screen. So in a few seconds you will see what I see. Yes. And this is the basic application. So I'll just enter 1 here, 0 here, and let it calculate. And now every 5 seconds it will call the API. For those who don't trust me, let's see the console. Yeah, it's calling the API, and when the model updates, it will give different result, and also it will give different version of the model. Okay, now before we proceed, I'm going to show you something also quite terrible, but bear with me. I'm going to update the model weights, and because the pipeline takes some time so that we get the results by the end. So I'll do it now, and then I'll explain what I'm doing. And I think I have it. So I'm opening editor, and the machine learning model composes of 2 constants, a and b. That's what's going to be. A is multiplied by x, and b is multiplied by y.
Sorry, can you put the font higher, please?
I will try, but this is Windows, so I'm not really sure. I probably should be able to do it. Okay, better? Okay, cool. I learned something today. Okay, so now we have some version of the model deployed, and we're going to change these constants. So I'll make it simpler to make it large numbers so that we see the result. Save it. I'll put it into the repository. Change the keyboard, new model, something. Let's try this. Oh, it's not working, and I don't see what I've written there. Well, this is the thing when you do live demos. Okay, it works like that. So we are a default user now. Okay, so we push the code. What I did for those who are not devs or don't know Git is I changed the weights, that's sort of changing the modeling script, and I pushed it to the repository. Now something is going to happen in the background. I'll show you quickly immediately what, and then we'll get back to it. This is my repository. It's open. The pipelines are visible. So you can see it. There is a pipeline running, and I'm going to go through all of these steps. So these are the steps. Now let's get back to the presentation and continue. Okay. So now we change this model. So we have a new model version, and let's go through the steps. What's happening? So first is the estimation. Second, there is using the model weights. Then it's testing the image. And fourth is deploying it to the cluster. I will go through the steps step by step. So first, the estimation. So what we do in the repository, there is a file called estimate, which can be your notebook, can be whatever. It's a Python script for this case. And the only thing it does, it saves two numbers, the two constants, A and B. But you can think about it that it's a model of any complexity. It's a pickled model in Python, but it can be neural network weights or whatever you like. And you save it. To make it sort of more independent, we save it to AWS S3, which is blob storage. Now the important thing is that the guy or the girl who does the model, they do not save the weights manually. The important thing is that they prepare the recipe, how to do it, and then they let the pipelines, I'm using GitLab pipelines for this presentation, do the calculation. So that's why you check two things. First thing is that you can do it again. And the second and more important thing is that it's not person dependent. And you will immediately see if it's incorrect, if it fails, for example, in getting the data from SQL database, if it fails in the estimation, if it fails while saving the model weights. And that's important. You have the trackability of what's actually happening. So this is the script. This is something I changed. And we commit the trick to version it. I mean, you can have a better versioning system. For this presentation, I used the Git hash of the change. So it actually gives me almost unique identifier for the version of the model and for the resulting weight. And then I'm going to use it also for the Docker image that I'm going to use. So this is a consistent way how to mark it, and you can replicate it. This is not something I'm using at work. This is not what we do, but this is actually it's a trick way how to keep versioning simple, be able to show it, and nicely show it in the pipelines and not to play around with some versioning scripts. So this is the estimation. Now the trick is, maybe I can skip this step. For those who know Docker, you will recognize recipe. So this is describe how you estimate the model using the script, which you run Python and the estimate script. The trick is that at the end, you take the sort of artifacts of the estimate script and push it to copy it to AWS. And this is where you use actually the versioning. So we create a pickled file that we call something yat, and that's the SHA hash. That's the hash, Git hash. This Docker file is actually not used. You throw it away. You just use the Docker capabilities to quickly be able to run a script without need to set up GitLab environment. This is a little trick. Now, Searpent. So, to sum up, at this stage we have the model. We have the weights, we have the model, and we have weights in AWS. Now, to be able to serve it, the API, we need to take the weights and put it into something that can actually respond to the API calls. For this simple example, I also used Flask because it's very simple to do a REST API. And the trick is actually that you create such a simple server, and the server, when it starts, it expects the weights to be somewhere in the files system. But for this template, you don't copy the weights there. You just prepare the template. And then every time you build a model, you do these things and push the new model into the repository. Now the trick for Docker is that but this is something more technical for those who don't know it. Layers, sort of parts that are being used again and again and saved again, are saved only once. So actually, even the Dockers are very small and they do not consume any more space than just the weights, theoretically of course, but that's sort of the idea. So this is how we prepare the server template. You have it prepared in the repository that you can access. Now the weights are going to be copied into the data. So how we build it? So first, we download the weights, and now we're in the pipeline, so we have the git hash, so we have the version of the weights. We download it, as you can see here. You download, you copy it from S3 to here, current directory. And this is the serving template we did in the previous step. And from the downloader, this part, you copy the weights to this folder. That's basically it. And this is the resulting Docker image that you push to the registry, and that's something that you can already use in production. But there is a step in between. And the step in between is the integration test. So what you can actually do is once you have your new model wrapped in the serving template in the registry, you can do something like dry run. You just download it, run it, test the API. This is just simple, let's say, smoke test that it runs, sort of response. It's more of a, let's say, API test that the API is correct. But you can also do some golden data testing that you prepare for this model. It needs to return these values with this input. So you can be more sophisticated, so you actually check that it's correct. And when this step is correct, you can use it in production. And you can do it automatically if you're brave enough, or you can just wait for some managerial okay, or you can go through some extra environments, you know it. Also, the important trick here is you can use sort of this hint, but that's more technical, so that you can actually get the exit code from the testing Docker that tests the environment. So it nicely finishes, and the Docker, the GitLab pipelines know whether it fails or not, so you can nicely continue or kill the whole pipeline. In our example, we do swarm deployment. So imagine that you don't have Swarm ready, but you somehow need some things, you need to install some dependencies. But basically this is how you start the environment. It's one command. Don't do this, don't do only this in production. You need to set it up better. I recommend some certificates and things like that, but it's very more complicated. Then you deploy the basic stack, so you tell it run this model. Once that's running, we call it machine learning meetup _ model. And in the pipeline, I'm calling this command. And what it means update the running service machine learning model, update it, and use this image, that's the server, with this version, that's again the hash. So throughout the whole pipeline, we have consistent versioning, update the delay 2 seconds, meaning that if you have more replicas of the model running, it doesn't roll over each other and do it all at the same time. It waits and gradually replicates. You usually fine-tune this with how long the model is starting out. If somebody of you do convolutional neural networks, you know that the weights are quite large, and we have some models starting for about 2 minutes. So this has to be tuned to that. Sorry, we use 2 minutes because the model started about 1 minute. And then this is good to tell it what should it do when the new model fails, because it starts, and if the container fails, you roll back. So that's also a good trick, so that you come back to the old model and don't screw up the whole cluster. Okay, let's see how we're doing in the pipeline itself. Okay, the pipeline seemed to be finished. Okay, so first is 10, and the other one should be about 10,000 or whatever that was. Yeah, it's 10,000 and the model weights changed. So this happened while we were discussing it. And it was completely independent from the modeler, which was me changing A and B, right? So this is how it should be done. the people who are modeling, they should focus on what they do the most, model things, and what they do the best, of course. People who can set up the pipelines should set up the pipelines. The modeler should be aware of what's happening in the pipeline as well, how they should prepare the models, for example, how they should prepare the integration tests and things like that. But basically, this is how you can very smoothly deploy models into production. And you know the version, so if the model is not performing well, you can always go back. If you're using Kubernetes, you can do some fancy things like run the model only for 10% of my requests. You can do that. Then see the differences, for example, in conversion rates, or however you have it set up for whatever the model is. If it's doing well, okay, let's increase it to 30%. So you can do these fancy things, and Kubernetes can automatically redirect the traffic. And yeah, this is basically it. Not yet. Not yet. We still have a summary. So to summarize it, the important, I have 5 keys related to 4 steps. So the first one is develop model as a code. Treat it really as a code, because essentially it is a code. No matter if it's an old school Stata, SPSS, or these old school corporate things that are so closed source that they barely have any new things, then have it estimate automatically. Just separate the people that are actually creating the models from creating the actual parameters. I remember when I worked in one bank, in credit risk, the scorecards were estimated locally on a computer, on a data set that had no script how it was created. Then these weights were put in a report with all these, you can imagine old school statistical report with all the graphs and everything. You have the ROC curves, and it was, very good work. But then there was a table of the scorecard, actual parameters. This was signed by the CRO or whatever during a meeting, and this was given to IT, and they literally copied it from that report. Actually, this was the process. I'm not joking. So treat everything as code and do it automatically. Then, of course, you have to version it, because then it's very easy to spot when something went wrong, because you know what version is running. That's the Docker image trick. You can think about it. And then test what you build, right? So you can use the golden data test if you like, or some regression testing. Maybe that's regression testing may answer your question about Python 2.7 and 3.7, 3.8. That you can actually build your Docker with 2.7, adjust the scripts with the same weights to have it run with newer Python, and then you can test both. With some basic data, you can run it in the development environment and test it, and see whether it's actual regression testing that you check whether the things are identical. So you can do that for models. It would be quite difficult for some models, but you can do it for most. And then you have to deploy it elegantly, which is one command usually. And one command that you don't have to write. But you've written once, commit it, and then it somehow works. Everything is in that repository. And now it's time for questions. And by the way, this is where you find the whole thing. This is not my standard repository. I don't do a lot of open source because I'll be ashamed of my code. But this is for this presentation. And there are results of the pipelines. There is a Git history, so you can have fun with these final commits. And yeah, it should work like that. So now, time for questions.
You mentioned credit risk or regulatory fields, and there are methodologies. For instance, methodology to create model like CRISP or another. So does exist any methodology which is coping with the subversion of logs and this kind of preparing model?
I'm not sure whether I understand correctly, but basically you can apply sort of versioning of the model to anything that produces scripts and something that can be used as a text. So for Excel models, It's hard to use, but for anything else that results in a text file, no matter if it's Python script, R script, you can use versioning. The only thing is and also there's one important side effect of this. If you use versioning and some reasonable way how to deal with the code, you can actually have your peer modelers review what you did before you actually commit it to the let's say production branches, to the production code to master. So you can actually treat it really modeling with these dev toolset. So whatever you produce, there are people looking at it and giving you feedback, right? So you may present them with a report, but also show them the code how you did it. They may spot some typos, they may spot some even data leakages between different variables, and way sooner than in production. So this can be applied to anything, basically. Only the things around might be different, because you may have some, I don't know, SAS expensive way of deploying credit risk scoring models, but still you're deploying scripts. So you should version. That should be the takeaway.
How do you version data sets?
Yes, that's very good thing. I mean, you can do a lot of tricks. We work with images, so the data sets are huge. So we use AWS S3, and we sort of have repos for transforming the data set. So we have some, if you imagine, the images that we use are usually a bunch of images somewhere. There is a meta file to it that links the bunch of images to something important like annotations and things like that. So this is somewhere in the repository. Then you have script that takes these data or some other data or combines them and creates a new data. So this script should be also part of the code. It might not be used when running it because you already run it somewhere and save the data, but even this should be handled. It was either completely clear or completely unclear, and it's useless to ask any questions.